The kinematics variable are distance, displacement, speed, velocity, acceleration. We don't bother about the force or how much mass of that body affects it. So straight line motion is also called as rectilinear motion. Only one coordinate is required. And then we saw the examples that same motion can be represented as two-dimension, 2D motion. Same motion can be represented as 1D motion by shifting or by rotating the position of our coordinate axis. So if you say that a ball moving in a cricket ball hit along the ground, is it motion 1D or 2D? A cricket ball hit along the ground is motion one dimension, two dimension. Are you getting my question?
Sir, one dimension.
Both. It may be both, depending upon the position of axis. Right? Just like we saw that inclined plane, a body is coming down the inclined plane. Motion is 1D or 2D. It will depend upon where you put your axis. So, anyways, its motion is straight line. That's for sure. It's 1D or 2D. That will depend upon the position of axis where you put it. Okay, distance and displacement calculation हम कर रहे थे कुछ numericals. Distance is the total path length covered. Displacement is the shortest path length distance along the line joining initial position to the final position. That's called displacement. So when a body moves on a straight line path, if it doesn't change its direction, okay, so I will also be taking some questions from the assignment that is supposed to send you in your group, but yeah, we'll be solving some basic questions based on that in today's class, right? Then Friday also we'll discuss that, but some questions we'll be doing here. So like first thing we did distance. Distance kya tha? Total path length covered in the journey. Total path length irrespective of the direction traveled. It's called distance. Displacement is always along the line joining initial position to final position. And this is a vector quantity. It is the line joining always initial position to final position. It's a vector quantity. Distance cannot decrease with time. Distance is always greater than displacement. Equal to displacement. Distance can be equal to displacement only under one condition, when the body is moving in a straight line without changing its direction. Right? So distance has to be greater than or equal to magnitude of displacement in general. This is the general criteria. If we have to calculate distance in some of the question, then we have to check that whether the body is moving just in a straight line without changing its direction, or there is a change of direction is also involved. Distance is equal to displacement only if the particle moves in straight line without changing its direction. Without changing its direction. Okay, very nice. So yes, we did few questions to calculate the distance and displacement. Next question. Last class के किसी question में doubt हो तो भी पूछ लेना. And I think we did very simple ones. Yeah. Next question is a particle moves. मैं थोड़े से टेढ़े मेढ़े लूंगा question. Not a particle or object कुछ भी. A particle moves 30 meter towards north, then 40 meter towards west. Particle को insect कर लो, थोड़ा more practical हो जाएगा. An insect moves 30 meter towards east, towards north, 40 meter towards west. and then 50 meters upwards. Find the displacement. Magnitude से find the displacement of the insect. Distance में तो direct add कर लेंगे, not a problem. Displacement of insect. 30 meter north, 40 meter west, and then 50 meter upwards. Find the total displacement of the insect during this time. Yes, try. We'll give the hint. हम अभी तक जो यूज करते थे नॉर्थ साउथ डायरेक्शन कुछ हम रफली सा बना लेते हैं. That is technically incorrect क्योंकि हम ऐसा कुछ बनाते हैं. This is the north and this is south, east and west. Okay, Anara, where is the upward direction? Where is the upward direction? Anara, are you there?
Sir, is it 50 to 2 meters?
Yeah, it's 50 root 2 meters. I'm just asking where is the upward direction?
Sir, ऊपर ही होएगा.
नहीं, ऊपर मतलब अगर हम नॉर्थ साउथ ईस्ट वेस्ट ऐसा शो करते हैं, then where is the upward direction?
Out of the plane.
Sir, west only.
Sorry, out of the plane.
Out of the plane, upwards. Right. So हम इसलिए जो show करते हैं, that is technically incorrect. We have to represent it like this. This is north. This is south. Here it is east. This is perpendicular. West. This is up. And here it is down. That should be the correct direction of representation. So we start from some point 30 meter towards east, 30 meter towards east, 40 meter towards west, 40 meter towards west, 40 meter towards west, and then 50 meter is going upwards like this. So if we want to find the actual displacement, हम ऊपर की तरफ north show करते हैं, but that is only when we don't have to use the upwards or downward direction. This is going upwards, so north and south will be on the ground only, up and down will be above, upwards and downwards. So now here initial position is this, A to B, B to C, and C to D. We have to find this displacement. So how do we find this? If we make a cuboid out of this, because it will be the three perpendicular axes from A to D. If we join, this becomes displacement, which is the body diagonal. What is the length of the body diagonal? Formula: root of A square plus B square plus C square for a cuboid. Understood? So 30, 40, and then it is going 50 upwards. A is 30, B is 40, and C is 50 meters. So 30 square plus 40 square plus 50 square. And this on solving will become how much? 5,000. It will be 50 root 2. 50
Yes.
root 2. Yes. डायरेक्शन भी हम लिख सकते हैं वैसे एंगल के टर्म्स में थ्री, बट अभी हमने क्योंकि वेक्टर पढ़ा नहीं है, सो जस्ट लीव इट. अभी हम सिर्फ कुछ सिंपल से क्वेश्चंस करेंगे टू फाइंड द मैग्नीट्यूड ऑफ डिस्प्लेसमेंट. दैट्स नेक्स्ट क्वेश्चन. बेटा ये समझ में आ गया सभी को? अर्नव, शर्मा, नायरा, okay, hopefully. Next question. Anara, are you there? Okay, very nice. Right, next question is, a particle moves on a circular path of radius r. Calculate the ratio of distance to displacement in 3.5 rotation. Take second. Yeah, I was just checking few students have not joined. Yeah. Calculate the ratio of distance covered to displacement. Distance to displacement in 3.5 rotation. So this particle is moving on a circular path only, and on this circle is covering the suppose starting from point A, it covers 3.5 rotation. 3.5 rotation means one complete will be at A, another complete again at B, then another at A, and then finally half rotation means the final position will be B. If it's starting at point A, that's the initial position, the final position will be at B. So displacement is pretty forward, that will be the diameter. Displacement is AB and that will be equal to 2R.
Is it 7 pi by 2?
Okay, distance is 3.5. 3.5 means 3.5. It is straightforward in one rotation 2 pi r. So it will be 7 pi r. Now, why I took this example, it's very easy, but it was asked in the exam and some of the students made it wrong because they didn't know the value of. Okay, what is the answer? Let's check how many of you get the answer. 7 pi r divided by 2r. Rishit, you got 5 something.
No, I said 7 pi by 2.
Achha, you said 7 pi by 2. Okay, but this was not in the option, by the way.
Yeah,
What is the
I
value of pi?
solve it further.
What
22
is the
by
value of
7.
pi? 22 by 7, yes. So the answer was 11 actually. When you put pi as 22 by 7, it will become 7 by 2 into 22 by 7. So the ratio was 11. So many students leave it because there is no option in this. 7 pi by 2. I mean, you have to use all the values. Pi is 3.14 and it's also 22 by 7. This is when the particle is rotating on its axis or a circular path. Next question. Next question is that a particle on the wheel is touching the ground at an instant shown. Find the displacement of this point P. Find the displacement of this point P in half rotation. In half rotation of wheel, if it is rolling on the ground without slipping. If it is rolling on ground without slipping. Yeah, so the question here is the difference between this question and the last question is, in the last question that was a circular motion on its own axis. Now this is a wheel, so just like the car wheel, they move forward as well as rotate. Here are these two motion, it is moving forward as well as rotating. That motion is called rolling. If there is no skidding, it's called rolling without slipping. That we'll also see in detail in the chapter of rotation. Point P is the one which is currently touching the ground. Radius of this wheel is R. In half rotation, we have to find. So in half rotation, it is moving forward as well as rotating. So because of the rotation, it will become it will reach the topmost point. And since wheel is also moving forward, so it would have covered. This example we did last class? I don't think so. Half
No, sir, we didn't.
Half rotation, it will cover distance equal to half of the circumference in the forward direction, and in the vertical displacement is 2r. Initially t is equal to 0, the point was just on the ground. Finally the point P has reached to the diametrically opposite point, but it has also moved forward because of the motion of the wheel. So the line joining initial position to final position, that will be the displacement. If it would have been only rotating, then it will be just 2r. But now this is rotation as well as motion forward. So the displacement of this particle P, displacement of this point P will be, by using the Pythagoras theorem, pi r square plus 2r square. Root pi square plus r times r. Right? So by the same logic, after exactly one complete rotation, it will be back on the ground. So it will become 2 pi r then. So that's how we can calculate distance and displacement equation. And we are using only the one dimension one, 2-dimension, 3-dimension. We require vector approach that we will see in the next chapter. Next is speed. First variable was distance. Distance is the total path length traveled. Displacement is the shortest path length. Speed is the rate at which path length is covered. Speed is the rate at which path length is covered. And when there is a rate will be always defined in two different ways: average rate and instantaneous rate. The rate at which path length is covered is defined as speed. So if there is a rate involved, there will be two type of rate. One will be average speed, another will be the instantaneous speed. Average speed will be over a large interval of time, over an interval of time, the total distance traveled per unit time. The total distance covered per unit time, irrespective of the direction, irrespective of the journey, what happened in between. Total distance covered in unit time is defined as average speed for a time interval. At any instant, if we have to define, then we have to differentiate. So average speed is total distance covered upon total time. So it will be S divided by T. Irrespective of the direction, irrespective of the motion, whether it is one dimension, two dimension, average speed is always total distance covered divided by total time taken, which will be S divided by T. It is again a scalar quantity. Why? Because it is the rate of change of path length. Since path length is scalar, time is already scalar. So it will be also a scalar quantity, cannot be negative. So speed we can calculate when we have distance, total distance, and total time. Instantaneous speed can only be calculated when we know the path covered as a function of time. Because we have to differentiate for the instantaneous rate of change, we have to differentiate for the average rate of change. Initial and final position, we will just calculate how much is the total distance covered divided by total time taken. Right?
Can you repeat that? My network is bad. I couldn't hear it. Your voice was breaking.
So my voice is breaking. Wait. Yeah, I think.
Due to my network.
Okay. Fine. So should I repeat?
Yes, sir.
Average speed will be over an interval of time. Instantaneous speed will be at one instant of time. Yes, Radhika, should I repeat? Radhika, should I repeat?
Yes, sir.
Average speed हम calculate करेंगे for a large interval of time. Instantaneous speed, we have to find one moment of time, and that will be only possible if we know the path length covered as a function of time. Instantaneous speed is for a very small interval that is represented as dt. So to calculate the instantaneous speed, we have to find the instantaneous change of path length over time, which will be differentiated as, which will be given as a differentiation of path length. ये हम पहले कर चुके हैं in the differentiation part. For a large time interval, it will be average rate of change. For a very small time interval, the rate of change will be ds by dt, where s is path length covered in time t. So it will be as a function of time t. Right? So we should know the equation of path length. Only then we can find out. Only then we can find out the instantaneous speed. So let's take one example. Speed, it is also a scalar quantity. It will also be in meter per second. But the difference is that instantaneous will keep on changing from point to point of the journey as your speed is changing. But the average will have one single value for the entire journey. Correct? So let's take an example. If suppose the path length covered in time t is given as. बेटा समझ आ रहा है?
Yes, sir.
Is there any new student? Okay. No. Fine. Anara, you joined late. Anara?
Yes, sir. I had joined earlier, but then there was a power cut, so I had to wait.
Okay. So suppose the path length covered in time t is given as s is equal to t cube plus 2t square plus 5t. Find the average speed. Find the average speed in t is equal to 2 seconds. Second, also find the speed at time t is equal to 2 seconds. So when speed at a certain moment we have to calculate, that is the instantaneous speed. पहले वाले में हम s total calculate करेंगे time 2 second में, and then we divide by the total time taken. Average speed is total distance covered divided by total time, or path length covered divided by total time. Instantaneous speed will be the rate of change of path length for that moment. It will be given by differentiation. So पहले वाले में average speed निकालनी है. Average speed is total distance upon total time. Total distance covered in 2 seconds divided by total time, and time is 2 seconds. So for that, we will put s t is equal to 2 in this equation, because ये equation represent करती है path length covered in time of 2 seconds. Total 2 second में जो distance covered होगी according to the equation given, we will substitute t as 2 in this formula of distance divided by total time 2. So it was how much? T cube plus 2t square plus 5t. T cube plus 2t square, so that also become 2 into 4 plus 5t divided by 2. 8 plus 8 plus 10 divided by 2. How much is that? 13?
13.
Average speed for the 2 second is 13 meter per second. Obviously, it's a scalar quantity, so there's no direction. We don't need to specify any direction. Instantaneous speed will be given by the differentiation. क्वेश्चन की लैंग्वेज से हमें समझना है कि एवरेज कैलकुलेट करना है इन 2 सेकंड मींस द टोटल टाइम इंटरवल इज 2 सेकंड. एट टाइम t इज 2 सेकंड इज द इंस्टेंटेनियस के लिए डिफरेंशिएट करते हैं, एवरेज के लिए टोटल डिस्टेंस अपॉन टोटल टाइम. दैट्स इट. डिफरेंशिएशन हमने थोड़ा किया था, फिर भी जो लोग भूल गए हैं एक बार फिर से हम बेसिक फॉर्मूला रिवाइज कर लेंगे. व्हेन वी हैव टू कैलकुलेट द इंस्टेंटेनियस स्पीड किसी इंस्टेंट पे फॉर अ वेरी स्मॉल इंटरवल ऑफ टाइम, वी हैव टू डिफरेंशिएट ds by dt, और इसमें हम बाद में टाइम को 2 पुट कर देंगे. द टाइम t सेकंड.
So 25 meter per second.
Okay, so it will be d by dt of t cube plus 2t square plus 5t. डिफरेंशिएशन का फॉर्मूला था d by dt of t raised to power n. Another, what was the formula for this differentiation? d by dt of t to the power n. Anara, what was the formula? N t raised to power n minus 1. Anara, you remember this formula?
Yes, sir.
So what will be differentiation of t cube? Quickly apply this formula. N here is t.
Three t square.
3t square. Very good. What will be for the second term? What will be for the second term? 2 को बाहर कॉमन कर लेंगे and t square will be 2t. And I'm asking you, t square differentiation by the same logic n is equal to 2 और 5t का हो जाएगा 5. So this differentiation will become 3t square plus 4t plus 5. This is an instantaneous speed at any moment t. So if you have to find t is equal to 0, you put t is equal to 0. Here we have to find at time t is equal to 2 seconds. So we will substitute t as 2 in this equation. So 12 plus 8 plus 5. 25 meter per second. 25 meter per second. इंस्टेंटेनियस स्पीड के लिए डिफरेंशिएट करेंगे, एवरेज स्पीड के लिए टोटल डिस्टेंस डिवाइड बाय टोटल टाइम. फाइन. अनरा डिफरेंशिएशन में अभी भी कुछ पंगा है क्या?
सर प्रैक्टिस करनी है बट साथ में यूटी भी आ रहे हैं तो मैंने अभी ध्यान नहीं दिया इस पे इतना ज्यादा.
यूटी में क्या आ रहा है फिजिक्स में?
सर फर्स्ट और सेकंड चैप्टर यूनिट्स एंड डिमेंशंस
और यूनिट्स एंड डायमेंशन और फिजिकल वर्ल्ड.
पर हमारे बुक में फर्स्ट 2 चैप्टर्स एक यूनिट्स है और एक डायमेंशंस, मतलब यही 2 आ रहे हैं.
यस
सर हमारे भी.
यूनिट्स एंड डायमेंशन. यस 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 फाइन. ठीक है. एवरेज स्पीड के और क्वेश्चंस कैसे करते हैं? दिस ऑल यू हैव डन इन क्लास 9 आल्सो. Average speed calculation for the different scenario. Ayush,
Yes, sir.
बेटा ये समझ में आ रहा है ना सारा?
Yes, sir.
Differentiation is comfortable now?
Yes, sir.
Okay. थोड़ी नई चीज है. It will take time, but yes, it is very, 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 very important. So we cannot skip that here. Okay, so average speed calculate करने के कुछ specific type के cases होते हैं. That let's see. 9th में वैसे आप ये सारे कर चुके हो. थोड़ा सा उसी में हल्का फुल्का ऊपर नीचे. Suppose a particle or an object covers. An object moves for time t1 with velocity v1, with speed v1 rather, and for time t2 with a speed v2, and for next t3 time with speed v3. So when he started, he maintains his speed v1 for time t1, v2 for next time d2, and v3 for next time d3. Calculate the average speed of this whole journey. Find the average speed of journey, entire journey. So formula for average speed is total distance upon total time. We'll calculate total distance. पहले t1 में distance covered s1, next t2 में s2, and suppose last t3 में it is s3. Average speed is total distance s1 plus s2 plus s3 divided by t1 plus t2 plus t3. Distance is velocity speed into time, so v1 t1 plus v2 t2 plus v3 t3 and divided by t1 plus t2 plus t3. So this is the formula that we can apply here. If this time interval is equal, then it will be just like a normal mathematical average or mathematical mean. So ये ऑब्जेक्टिव में लैंग्वेज वाइज क्वेश्चन आया था, इफ द टाइम इंटरवल्स आर इक्वल देन द एवरेज स्पीड इज अरिथमेटिक मीन। अगर ये टाइम इंटरवल सेम होंगे, इफ t1 is equal to t2 is equal to t3 then the average speed will be just the normal average, जैसे मैथ्स में मीन कैलकुलेट करते हैं, it will be mean of all of the three speeds maintained during the journey. एवरेज के लिए हम नॉर्मल v1 plus v2 plus v3 by 3 केवल तभी कर पाएंगे when time intervals in which the particle moves with a different speed is equal. Then the average speed will become mean of v1 plus v2 plus v3. It become the arithmetic mean. So ये क्वेश्चन की लैंग्वेज में कुछ ऐसे आया था, arithmetic mean or the normal mean of all these speeds. But for any other cases we cannot do that. Other cases means if time is not equal, distance is equal. Method is simple, total distance upon total time. Total distance हो गया s1 plus s2 plus s3. Total time is t1 plus t2 plus t3. s1 is v1 t1, s2 is v2 t2 and s3 is v3 t3.
सर
Yes बेटा.
सर वो आगे वाला पेज दिखा दो एक बार।
हाँ. Right, second case. Second case is suppose the particle covers first s distance with the speed v1, next s distance with the speed v2, and the last s distance with the speed v3. Or maybe we take s1, s2 and s3. A particle covers first s1 distance with the speed v1, next s2 distance with the speed v2. ये आप सभी को आता होगा, वैसे हम 9th में भी कर चुके हैं. Next s2 distance with the speed v2 and last s3 distance with the speed v3. Find the average speed of this whole journey. So in this case, the time is not mentioned. Path length s1 and s2 is covered with the speed v1, v2 and v3 respectively. Right, so we can represent it as like first s1 distance is moved with the speed v1, next s2 distance is moved with the speed v2, and last s3 distance is covered with the speed v3. If the time taken are t1, t2 and t3 in these path, average speed is always total distance upon total time taken. Total distance will become s1 plus s2 plus s3 and divided by total time taken is t1 plus t2 plus t3. So t1, t2 and t3 are not known here, that we can calculate in terms of the distance and speed. S1 plus S2 plus S3 divided by S1 by V1 plus S2 by V2 plus S3 by V3. Right, so that will be the average speed. अब इसी में question होता है first 1/3, next 1/3, something like some S1 को S by 3, S2 को 2 by 3, something we can write. So these are the two cases. एक में time के respect में होता है और एक में distance के respect में, and the third one is in terms of combined for both. Average speed of this journey will be S1 plus S2 plus S3 divided by time taken in the first journey is S1 by V1, S2 by V2 plus S3 by V3. Right. So like suppose in any journey, first 1/3 distance is covered with the speed V1. And second, the remaining journey is 1/3 of the journey is covered with the speed V1 and remaining is covered with the speed V2. Find the average speed of this entire journey. Find the average speed. Right, so if you consider this whole journey to be like 3s distance, S is 1/3, 2s is 2/3. पहले इसमें distance covered is V1. Next 2s speed is V2. पहले वाले V1 में suppose time taken is T1. Next 2s में time taken is T2. So if you calculate the average speed is just the total distance divided by total time. Total distance is 3s and total time is T1 plus T2. So T1 is the time taken in the first S distance with the speed V1. Time will be distance upon speed plus 2s upon V2. इसका S cancel out हो जाएगा ऊपर नीचे 3 divided by 1 upon V1 plus 2 upon V2. Take the LCM, so 3 V1 V2 divided by V2 plus 2 V1. The average speed of this journey, similarly अगर half हो then it will be 2 V1 V2 upon V1 plus V2. Right? Hmm. 3 V1 V2 upon V2 plus 2 V1. Right? So एक mix question कर लेते हैं जिसमें first half of the journey. Suppose the first half of the journey is covered with the speed V1. I think I can show this on this question also. We have okay, no problem. First half of the journey is covered with speed v1. And second half of the journey is covered in two equal time intervals. Second half is covered in two equal intervals with speed v2 and v3 in two equal time intervals. With the speed v2 and v3. Find the average speed of this entire journey. Right? So we have the whole path. Let's say it is 2s length. S distance is first half. Next S distance is second half. पहले S distance को cover किया v1 speed से. Time taken is suppose t1. Second half distance is covered in two equal time intervals. Let's say t2 and t2 are these time intervals. And the speed is v2 and v3. Yes?
So can we try the question once?
Yeah, you can try.
Okay, sir.
First half S is covered is speed v1. Second half is covered in two equal time intervals. So I just give the hint. पहले वाले के लिए हम time ले लेंगे t1. Second half the total time is 2 t2. First t2 speed is v2. Second t2 speed is v3. Right? Okay, please take your time. Solve this question. ये पिछले के जैसे ही होगा, बस थोड़ा सा इसमें हमें tricky, थोड़ा सा ये करना है, दोनों को एक साथ involve करना है. Average speed is total distance divided by total time. Total distance of this journey is 2s. Total time is t1 plus 2 times t2. So t1 तो आ जाएगा कुछ direct simple. t1 कितना होगा? t1 is s by v1. t1 is s by v1.
Yes, sir.
What about t2? t2 कैसे कैलकुलेट करेंगे? Yes, how will calculate t2? Anyone?
So S by 2 divided by V2 plus S by 2 into V2.
No, it's not two equal path length. We cannot take that the path covered is
T1
s
plus
by
V2
2
into T.
We can use this logic that the total distance covered in this time. So total distance covered is speed into time v2 t2 plus v3 t2 is equal to s. Total distance covered is speed into time. So it will be v2 t2 plus v3 t2. t2 will become s divided by v2 plus v3. t1 is s by v1. Understood the second part? t2 कैसे कैलकुलेट करेंगे? t2 will be the total distance covered in this 2 t2 time. पहले t2 time में speed थी v2, so distance का फॉर्मूला speed into time v2 into t2 plus v3 into t2. Got it? इन दोनों वैल्यूज को हम यहाँ सब्स्टिट्यूट कर देते हैं. So it become 2s divided by. बेटा किसी स्टेप का क्लैरिफिकेशन चाहिए हो तो पूछ लेना, घबराना शर्माना मत. This is S by V1 2 times T2, and T2 came out to be S upon V2 plus V3. Clear? Okay.
So can you show the last slide once?
Yes, beta, yes. First half is covered with V1, second half is covered with V2 and V3. Yes, calculate and give me the final answer.
Sir, 2 into V1 into V2 plus V3 upon V1 plus V2 plus V3.
Okay. SS get cancelled. It will be 2 divided by 1 by V1 plus 2 divided by V2 plus V3. Take LCM. So ये नीचे का LCM V1 into V2 plus V3 आ जाएगा. And it will be V2 plus V3 plus 2 times V1. Is it the answer?
Yes, sir.
Very nice. Okay, so average speed we can calculate by using this. Instantaneous, we require the distance equation in terms of time. We will differentiate and only after that we can find it. Any doubt to anyone? This question clear? Sia? Understood this? No doubt? Okay, very nice. Okay, so next part is the velocity, average velocity and instantaneous velocity. Right, so velocity is the rate of change of displacement with time. Again, the rate of change will be measured in two different ways, average and instantaneous. Average velocity will be the total displacement divided by total time taken. It is a vector quantity, so we will represent the vector symbol also, and we have to write the direction as well. Total displacement divided by total time taken. So total displacement, because it is the one dimension में displacement will be only final minus initial. x2 minus x1 divided by final time t2 minus t1. Average velocity will be total displacement. Total displacement is final position minus initial position. If the equation is known, then otherwise we will calculate by joining the initial line to final line. Right?
Yes, sir.
Okay. So इसको हम ग्राफ में कैसे कैलकुलेट करते हैं? एवरेज वेलोसिटी को, एवरेज वेलोसिटी इन द ग्राफ इज कैलकुलेटेड by using the slope of line joining initial position to final position. So graph we will do separately also. Graph portion we will do separately. Average velocity is x2 minus x1 upon t2 minus t1. Instantaneous velocity will again be done by the differentiation. Where x is given as a position, x is the position at time t. So if we differentiate x with respect to t, we get instantaneous velocity. Okay, so exactly similar thing that we did for the distance, but distance may we have to take the total path length. In the case of velocity, we just take the final position minus initial position. So if we consider any journey starting from A to B. So this is the distance covered along this whole path, and displacement will be along the straight line joining A to B. So distance is always going to be greater than the displacement when we take a large time interval. For any large time interval or for any time interval, distance is always going to be greater than. For any large time interval means not just any instant, maybe 2 seconds, 1 second is also a large time interval. Distance is always going to be greater than. Distance is always going to be greater than or equal to magnitude of displacement. If we divide both side time, the total distance covered divided by total time taken will be equal to the magnitude of total displacement covered divided by total time. Total distance covered by time is average speed. So in any journey, the magnitude of the average speed is always greater than or equal to magnitude of average velocity. Just like distance is always distance is always greater than or equal to displacement. Any journey for any large time interval, the distance is greater than displacement, and therefore average speed is greater than average velocity. But if you take any small time interval, just very small dt, so चाहे वो कैसा भी curved path हो, for very small interval, it will be like a straight line. And for every straight line, distance will be equal to displacement. So for a very small interval of time, for a very small interval of time, which is dt, the value of distance is always equal to displacement. क्योंकि बहुत छोटे इंटरवल में that path whatsoever curved it will be like a straight line only. इसको दोनों तरफ टाइम से डिवाइड कर देंगे, then it will become instantaneous speed. Average speed will be greater than or equal to average velocity, but instantaneous speed is always equal to the magnitude of instantaneous velocity. Reason is clear, because for such a very small time interval, it is not going to change its direction. For any instant, a very small change, instantaneous speed is always the magnitude of instantaneous velocity. And that is why it is always positive, because it is just representing the magnitude of a vector, modulus of a vector. Distance, okay. So velocity is vector quantity. It can be positive, it can be negative, or it can be zero as well. But speed will never be positive, will never be negative or zero. It is always going to be positive. So now if you have to calculate the average velocity in any journey, we have to find the total displacement divided by total time. So अभी हम average velocity वाले questions देखेंगे, just like we did for average speed and instantaneous speed. अभी तक इसमें कोई doubt? This is just theoretical part, but we have already done the same thing is repeated. पहले वो distance के लिए था, now it is for displacement. Velocity is final position minus initial position divided by total time taken. In the case of distance, we have to calculate the entire path length covered. In the case of displacement, only the initial and final position is required. So we'll see both the type of equation, the equation based and the diagram based. So like suppose if a particle moves on a straight line path, such that the position of the particle at time t is given as, x is equal to t cube minus 3t square plus 5. Find the average velocity in first 2 seconds and find the instantaneous velocity at time t is equal to 1 second. Average velocity in first 2 seconds. Also calculate the instantaneous velocity at time t is equal to 2 seconds or 1 second. Method is same, बस यहाँ पर हमें displacement calculate करना है. The last question it was the path length covered in time t was given. Here it is the position at time t. That position is changing. Average velocity is total displacement by total time. Delta x by delta t. Average velocity delta x will be x2 minus x1 divided by t2 minus t1. x1 is x2 is x at time t is equal to 2 second minus x at time t is equal to 0 second divided by time taken is 2 minus 0. Substitute the value of t and then find the answer. Yes.
So minus 2 meter per second.
Minus 2 meter per second.
Yes, sir.
Yes, sir. Same answer.
Okay. Very nice. T is equal to 2, you substitute, it becomes 2 cube, that is 8 minus 12 plus 5 minus, if you put 0, it becomes 0 minus 0 plus 5 and divide by 2. 5 gone, so 8 minus 12 minus 4 by 2, that's minus 2. So average velocity is minus 2 meter per second. For the instantaneous velocity, we have to differentiate. Now, what is the instantaneous velocity? Arnav Sharma. What the instantaneous velocity here? Differentiate and put the value d by dt of d by dt of t cube minus 3t square plus 5. Yes.
Sir, minus 3 meter per second.
Arnav Sharma, I asked you. What's your answer? Arnav? Arnav? Yeah, निकल लिए? Very nice. Okay, very good. Anurag, what is your answer? Differentiate and then Anurag, what is the velocity as a function of time? It will become 3t square minus 60. Anurag? Anurag?
Yes, sir.
What is your answer?
सर अभी किया नहीं सर, पेन खत्म हो गया था, कोई चेंज करने गया था.
Okay. At
सर
time
इसीलिए
t.
रिप्लाई नहीं कर पा रहा.
अच्छा अच्छा ठीक, कोई बात नहीं. हाँ, मुझे लगा 3 is equal to minus 3 meter per second. Is it minus 3?
Yes, sir.
Yeah. At time t is equal to 1 second, it is minus 3. Bhavya?
Sir, Arnav is saying he has mic issues.
Okay. Very nice. Average velocity, instantaneous velocity. So we are calculating with the help of equation. Next question. A particle move on a circle. So अभी हम straight line है, अभी हम general cases लेंगे when the particle is moving on the two-dimension path also. Find the average speed, average velocity in time of from A to B in half rotation. Find the average velocity of this particle if it is moving on a circle of radius r in half rotation. Time is not given, so time also we have to find somehow. Find average velocity of particle in half rotation on the circular path. In half rotation of circular path, if it moves with constant speed v. So it is moving on the circular path with constant speed of v meter per second. We have to find the average velocity from A to B. Average velocity is total displacement divided by time taken. Displacement is equal to diameter. So displacement तो हमें मिल गया यहाँ पे. That displacement is how much? Is exactly equal to the diameter, which is equal to 2r. How will we find the time taken? How will we find the time taken? Govind?
So displacement upon time है, so the time is equal to displacement upon average velocity.
अरे एवरेज वेलोसिटी पता कहाँ है बेटा, वही तो निकालना है.
So speed
Find average
constant रहेगी सर इसमें तो.
तो टाइम कैसे निकालेंगे ए से बी तक पहुंचने का?
सर इसमें ट्रिग्नोमेट्री तो नहीं लगेगी.
Trigonometry कहाँ लगेगी यार? How will you find the time taken to reach from A to B, because time is not given? Yes. How will you find the time? हाँ बेटा.
Pi r by v.
Pi r by v. Very good. किसने बोला?
Sir, Simrat.
Harsimrat. Okay. Yes, pi r by v, because we can take this time as total distance divided by time. So time taken is total distance. Time तो same ही लगेगा. Upon speed. Time taken from A to B will be distance. Distance is semicircle divided by pi r by v. So time taken to go from A to B is pi r by v. R are gone. 2 by pi times v, that is the average velocity from A to B. Right, that's the average velocity from A to B. Clear? In half rotation, the displacement is equal to diameter, but the time taken to cover is half of the total journey. So half is total journey will be pi r divided by speed, pi r by v. Right? Okay. What about in 1/4 of the rotation? Similarly, we can calculate 1/4 also. वो आप homework में कर लेना, calculate average velocity and average distance. Average velocity, average speed, it will be what will be the average velocity? Suppose in one complete rotation, the average velocity will become exactly 0, because in one complete rotation, the total displacement will become 0. So velocity, average velocity will become 0, not the average speed. Okay, so this is like the circular path, average velocity and average distance, speed, instantaneous speed, average velocity, and average and instantaneous velocity. These four concepts we did. Similarly, we can calculate for acceleration also. The rate of change of velocity is defined as acceleration. So they all are related with each other. Like the rate of change of distance is speed. The rate of change of displacement is velocity. The rate of change of velocity will become acceleration. So it is like acceleration is defined as rate of change of velocity with time. Again, when there is a rate, it will be always defined as average as well as instantaneous. If it is over a period of time, it will be average acceleration. The rate of change of velocity with time, that will be average acceleration, will be final velocity minus initial velocity divided by total time taken irrespective of what was velocity in between. Average acceleration, since it is a vector quantity, So हम initial velocity और final velocity को भी लेंगे with the proper sign convention. Sign convention as in, if suppose velocity is towards east, it is positive, then west it will be negative. East positive, then west will be negative. Only that sign convention we have to follow for one dimension. Average acceleration is change in velocity vector divided by time taken. And the direction of average acceleration will always be along the change in velocity. If velocity is increasing, it will be in the direction of velocity vector. If velocity is decreasing, it will be opposite to that. Instantaneous acceleration, again by the same logic, will be defined as the rate of change of velocity with time. So it is usually a very easy chapter, but थोड़े से कुछ conceptual questions आ जाएंगे when we have to change the frame. It's just the repetitive step. Displacement को position को differentiate करोगे, velocity मिलेगी, velocity को differentiate करोगे, acceleration मिलेगा. So since it is one dimension only, we are not drawing the vector sign. But when we do motion in 2D or 3D, then we have to represent them as vector components only in terms of I, J, and K. Acceleration is rate of change of velocity, instantaneous. A velocity was already the rate of change of position with time. So acceleration can also be written as d square x by dt. Second order derivative of position or displacement is acceleration. Acceleration is rate of change of velocity. dv by dt, it is also the double derivative of position with respect to time. Another formula that we derive, we can change acceleration in terms of x. From here, we will get acceleration in terms of t. We can change this acceleration from t to x by a small modification. Instantaneous acceleration is dv by dt. If we multiply by dx and divide by dx. Multiply by dx and divide by dx. And then we take this dx by dt together, rearrange these terms. It becomes dx by dt into dv by dx. थोड़ा ज़्यादा पढ़ लिया हमने आज, but we will have the questions on these on the Friday class. So that's why
Why did you do this?
बेटा देखो एक्सेलेरेशन यहाँ पे किसके टर्म्स में है, टाइम के रेस्पेक्ट में. बट देयर आर 3 वेरिएबल्स ना. वेलोसिटी टाइम के साथ भी चेंज हो सकती है, वेलोसिटी पोजीशन के साथ भी चेंज हो सकती है. When a particle is moving, there are 2 coordinates changing. X is also increasing and time is also increasing. Correct?
Yes.
Time is also moving further and position, this coordinate is also changing. So we have to find, we may calculate acceleration as a function of time, or we can also calculate as a function of x. तो टाइम के लिए तो हम सीधे dv by dt कर देंगे, because velocity is known as a function of time. You differentiate, you get acceleration as a function of time. But अगर velocity time के form में नहीं given है, velocity is given as x square plus 2x suppose, तो उसके लिए हमें थोड़ा सा rearrange करना पड़ता है फॉर्मूला. dx by dt become velocity, acceleration is v times dv by dx. Both of these formulas for acceleration, the only difference is the variable. When variable is time, then we do dv by dt. When variable is x, then we do v times dv by dx. Understood? Understood?
Yes.
So these are the 3 formulas. Your Friday class, we will do questions on these. अभी आप बस ये notes revise कर लेना. I will be sharing few more basic exercise. DPPs तो है ही जो मैं आपको share करूंगा, but उसके पहले क्योंकि ये chapter थोड़ा और practice चाहिए इसमें, basic level questions also before we go to the DPP level, right? So I think we did distance. We covered a lot of portion today. Distance, displacement, speed, average speed, instantaneous speed, velocity, instantaneous velocity, all the cases of average speed calculation. अगर स्पीड थोड़ी फास्ट लगी हो तो don't worry, we will do a lot of example on this in the Friday class, some from DPP and some more practice worksheet I will be sharing in the group today only. Okay, the concepts you have to learn with the 1 or 2 example, and rest you have to do the practice. So solve the questions from SL Aroda on this topic, instantaneous velocity and acceleration part, velocity and speed part. We will continue on Friday with more examples, numerical questions on it, and you can bring also all of your doubts. Right, so I am going a little faster because sir is also revising this. Anybody missing or not able to attend the sir's class, AP sir's class, please see the recording at least. It will give you a brief revision of the all basic concepts, and it will help you a lot. Right? Okay then. Yes, please revise these notes because it's very important, and these formulas, every formula has some specific application in particular situation. Okay, okay then, thank you.
Thank you, sir.
Thank you, sir.
Thank you.